Good morning, YouTube. Okay, so let's talk about the binomial expansion theorem. How do you FOIL a lot, basically? Alrighty. And this has to do with sequences and series, believe it or not. Okay, so you tell me. What is x plus 1 to the 0? Anything to the 0 is 1, right? Okay. What's x plus 1 to the 1? X plus 1. What's x plus 1 squared? X squared plus 2x plus 1. You can FOIL that in your head? You know that, right? Okay. All right. What's x plus 1 cubed? Go ahead. It should be just as easy. Because I'm not FOILing. What am I doing? The binomial expansion theorem. Do you know this thing? Look at the coefficients. Tell me. Name the number. 1. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. What am I doing? Pascal's triangle, right? Okay, so it's 1x squared. Whoops, wrong. Back. It's 1x cubed. Okay, what do you think? But 3x squared plus 3x plus 1. Right? Do you know Pascal's triangle? Okay. So what are the next coefficients? 1, 4, 6, 4, 1. Pretend that's a 0. What am I doing? I'm taking the number above plus the previous one, right? Sort of like a recursion. Ooh, remember recursive sequences? We did that, yeah. All right, so what should I write for the FOILing out? X to the 4th plus 4x cubed plus 6x squared plus 4x plus. What happened to my smartboard? It's being dumb. Plus 1. Okay. My smartboard took a powder, but that's okay. We're going to go to Sage and do the same thing. Amazing. All right, so log into your local Sage. La la la, la 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 la. Let's see, over here. And open up this executable script. Run in terminal, and log in as you did previously. Hang on, wait for the prompt. Should say Sage colon. Give it a sec. Come on, prompt. There it is. And you type exactly what it says here, right? Because you didn't log in yet. Okay, so go to Notebook. Well, then you didn't log out and people were using your account. Ooh, bad. All right, so this is the open account that anyone can use. I want to sign out and log in with the username you made up. And what did I make up? I think it was Shadowfax. And that's the last thing we did. 12:04. What's up? I won't let you go. What did you do? You did, okay. Double files started. Another Sage notebook is running already? Really? Hang on. Just see that. Yeah, okay. So, all right, let me do this. What do I want to do? Another terminal. No, probably all I have to do is this. What was it? 1945. All right, now let's see what it says. That's different. Yay! Okay, you good. All right, anyone else stuck? Yeah. Tuesdays and Thursdays right after school, right here. Today is Monday. That's good. That's why you're in a group and you're working with other people's brain cells. Yeah. All right, so anyone else stuck? Unable to connect. Why is this? Well, you could do that, I guess, but 2002. What? Someone didn't close their Sage server for last time. That's all it is. They messed it up. All right, let's try it again. That's different. Who else is stuck logging in? Okay, the problem here, it seems that people didn't log out last time. Okay.
It says the username and it keeps on capitalizing it when I don't want it to.
Isn't that fun?
And that's not my password.
Huh. That's weird. Yeah? No, the one, well, then we changed it. You changed it to something else. Why is it's supposed to be like that? Lowercase? Wow. Why is it doing that? That's very strange. How about we try this? Dang it. How many eyes are there? Whoa, what's with the keyboard? Oh, this keyboard's screwed up. What's wrong with this keyboard here? Go away. Settings, manage users. You're not in here. Yeah, so let's add you. Make a username. All right, now wait, don't get crazy. You're getting crazy.
No, I was gonna copy.
Oh, you were? Okay, just just making sure. All right, so sign out, try your new login. And then highlight that, paste, right? Okay, get in there. MU. Is it?
Yeah.
Oh, you dumb computer. Why is it doing that? Holy Mazola Cornell, Batman. Well, let me do that, right? Okay. You know, just when we thought it was safe to use Sage. Wow, this keyboard. What is with this keyboard?
Why the hell did you block me on Facebook?
Oh, dang it. You know. Wow, something's really wrong with this keyboard. All right, you know what? How about we do, it's there. How about let's break down and use a capital C, huh? Alrighty. And alright, copy the password. Alrighty. Hold on, go to sign out. And now sign in with a capital C. And put in the fake password.
Okay, I took it from some guy and removed it.
Amazing. Now change the password. Go to settings.
Yeah.
Up there. Click again. Okay, go to, okay, control, paste it there, right? Change it up and you should be good from now on. Okay, who's not logged in? Oh my goodness. Whoa, my mic just got smashed. Sorry, YouTube. Hang on, coming around. Why is it doing that? Let's find out. Really? Oh, stupid computer. Whoops, sorry. Hang on. Let's see. I'm going to do this. I'm going to do this. What is it? 1947. Let's see if this works now. Goody, goody, goody. All right, who else isn't logged in? Problem over here, we good? You're not logged in?
I think I'm in a guest account or something.
Yeah, that would be admin. You don't want to be admin. So go sign out and use the password. Is this you?
Yeah,
All right. And did you sign in? Username is not in the system. Did you create this account?
yeah. This is a account I created.
Let me try some. see what users we got in here. Not in here. You sure you created an account?
Oh.
Oh, you Jang?
Yeah. I mean,
Which one are you?
I'll use the regular Django.
All right, do you know the password you made for that?
Yeah.
You sure?
I think so.
All right, then use it. Okay, you got to know your login name. Hello. Are you okay? Okay. Are you guys at the point where it's asking for file name, right? You know, new worksheet or whatever, right? All right, let's do that. All right, so new worksheet. Okay, this is going to be 1205. Put your name in here in case you want to print it. Where am I? What is this? What is the binomial expansion theorem? Oh my goodness. Okay, there you go. So let's do what we just did. Okay, let's see. All right, what did we just do? We just did x plus 1 to the 0 is, okay. Okay, then x plus 1 to the 1 is, this got to be an easy way to do this. Do we really have to type this over and over again? Any ideas? By the way, it didn't do it, did it? What happened here? What's missing? How do you make it foil for you? Expand. Okay, how about we do expand of that? Okay, that looks good. I want pretty print. Okay. So, what if I wanted to do this in one line, or maybe a couple lines, and generate a whole bunch of these? Is there a way to make it repeat something over and over again? Have we talked about this? Have we talked about loops? Do you remember the loop? Yeah. The only thing that's changing is the exponent. I need a loop that's going to count from 0 to, I don't know, 5 or something, and see what I get. Right? All right. So get rid of this. Get rid of this. And get rid of this. But we're going to do it this way. All right? Expand. Right? Okay. And let's do it like this. 4. Do you remember this? How do I generate a whole bunch of exponents like 0, 1, 2, 3, 4? 4. For n in range, what? Well, if I do 5, what's that going to do? It's going to 0 to 4 technically, right? It's 5 integers starting at 0. Okay, so let's write what we wrote. Expand quantity x plus 1 to the, well, what? To the n, right, exactly. And there you go. All right, so I can get rid of this. I can get rid of this. If you want to get crazy, make it 10. Okay. Wow, that's calculated in real time. Ooh, and you're all doing it at the same time. Whoa. Wow, this is crazy. All righty. So, how do you get those numbers? How do I get the 5 or the 15 or the 35 if I don't know it by hand? Huh? The triangle. What if you're too lazy, you don't want to draw the whole triangle?
Oh, the formula.
There's a formula for that, right? Do you remember? Yeah, I remember. Didn't we talk about this? Let's see. Is my smartboard back? Well, no. Let's talk about that. How do we get those coefficients if I want them? Let's see. It's back. Okay. All right, so here are the numbers. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. You tell me. 1, 5, 10, 10, 5, 1. Now, how do I calculate, say, this one without drawing the whole mess? There's a quick way to do it. Do you remember? Huh? Which is NCR. I need NCR. All right, so if N is the row that you're in, and R is the column that you're in, and remember, we like to start counting at 0. So this is N equals 0 row, 1 row, 2 rows, 3 rows, 4 rows, 5 rows. And this is R equals the 0th column, the 1th column, that's not English, 2th column, 3rd column, 4th, 5th column. What am I looking for? 5C2. How do you do 5C2 or NCR? Do you know? Okay, good. So, all right, let me write in. NCR is n factorial over r factorial. You said that much. What else? Times n minus r factorial, right? So let's do it. It's what? Who's n here? So 5 factorial over 2 factorial times 5 minus 2 factorial is 5 factorial over 2 factorial over 3 factorial, right? Well, let's find out. Let's see if there's a quick way to do this. So 5 factorial is what, really? 5 times 4 times 3 times 2 times 1? All right. 5 times 4 times 3 times 2 times 1 over, well, 2 factorial? 2 times 1 over 3 times 2 times 1. Notice these go away automatically. A quick shorthand way, I think they probably did this in Algebra 2 and Trig, didn't they? If you're doing 5C2, you write 2 lines, 5C2, and you count down from 5 and you count down from 2. Isn't that all that's left? So it's 20, 20 over 2 is 10. Is that what you expected it to be? Okay. How about this one? What's 5C5? Why, though? Can you do it this way? What's 5C5 according to this? Well, let's see. 5C5 is going to be n factorial, which is the first 5, over r factorial, which is the second 5, over 5 minus 5 factorial. So, well, 5 factorial divided by itself is 1, and that's what we said it would be, right? Then we said it's going to be 1. Okay. So guess what 5 minus 5 factorial is? 0 factorial is 1. Did you know that 0 factorial was 1? Did you know why? Because Pascal's triangle wouldn't work otherwise. That's why. By definition, 0 factorial is 1. Okay? All right, now, let's sagify this. Yeah. Well, that's the same rule we had before. NCR is n factorial, the first number, over r factorial, the second number, over the first minus the second. Over, right? So that's the 5 minus the 5. Yeah, I know. Stop. So 5 minus 5 on the bottom, right? Okay, can we do this on Sage? Can we come up with this rule? Let's see here. Let's see. All right, well, if we go back to Sage, where did my Sage go? There it is, okay. All right, look at this. Factorial. Factorial of, I don't know, 5 is 120. How can I draw like a table of factorials? What if I wanted a whole pile of factorials? 1 factorial, 2 factorial, 3 factorial. You would write another loop with a range, right? So, all right, let me get rid of that. So 4, how about I? It doesn't have the n all the time. In range, 10. So I is going to be what? What are the I values? Range 10 means 0 to 9, integer y's, right? So let me just print out the factorials of I. There they are. Notice it started with 0 factorial, right? Because range 10 starts at 0. So 0 factorial, 1 factorial, 2 factorial. If you want to make it more obvious, how about we write down what I is? Let's see. Print I, comma. How about a tab? Remember this tab stuff? There you go. So 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, but you knew that, right? Want to make a little heading maybe? How about print, quote, I \t, factorial of I. How about that? Just the label stuff. All right, so now you got headings on your columns, okay? So those are the I's, and those are factorial of I, yeah, okay. Or if you want to make it short, I factorial. Ta-da. Okay. So now how do we make that rule? How do I make this rule? How do I do this? How do I enter this into Sage? How do I get it to, right? If this is 0, 1, 2, 3, 4, 5, 6, 7, 8, the ninth row, 0, 1, 2, well, it's not the ninth row because I started at 0, right? And 0, 1, 2, 3, the third column, really the fourth column. How do I calculate 9C3 if I want, without doing all of this? How do I get Sage to do this? I want Sage to do this for me. It's all based on factorials, right? So you could do this. Let me call this function, I don't know, combo. Define combo, because it's combinatorics. NCR is combinatorics, right? You know that stuff? So how about combo, plug in N and R, and what do you return? Well, you tell me. How did we do NCR? What goes on top? N factorial over R factorial over N minus R factorial. So write that. Factorial of N divided by the factorial of R divided by the factorial of N minus R. Okay. Now let's see if this thing works. Didn't we do 5C2 was 10 a little while ago? Let's try that. What's the combo of 5, 2 should be 10? Amazing. All right. How about this one? Didn't we say this was 9C3? 9C3? Let's see. Let's put in 9 and 3, and we get 84. Didn't we have 84 up here? Right? Okay. Now, what's weird about this? Would you have written it that way? Isn't it, this whole thing is a denominator, R factorial times N minus R factorial? Is this equivalent? Let's see. Well, if you put parentheses around it, then you'd have to multiply. But remember how to divide. You multiply by the reciprocal. So I was actually dividing twice is multiplying by the reciprocal. Look, you get the same answer. You could write it either way. You could do it like that, or if you want to leave out the parentheses, just make this a divide. Same thing. Okay, who's stuck? All right, come around. Hang on. Spelled factorial weird somewhere. Here. Yeah. Ta-da! All right, got 84? Yep, push that back. Go to the beginning where it says combo on the third line. Yep, space it, all 4 spaces. Now run it. There you go. Right, 5C2 is 10, yeah. You got the 84, you got the 10, whatever, 5C2, 9C4. You got it, you got it, you got it. Let's see your Sage. You got it? You got the 10? You got the 10 or the 84, whatever? Yeah? Yep. Mm-hmm. Let's see how you're doing. What happened? Oh, you got it, right. That's good.
It's like so zoomed in.
Huh?
It's like the whole screen is just Sage.
Okay. Oh, you must have gone full, screen, whatever. Up. What happened? Factorial of N over factorial of R. Right. If you're going to divide twice, you don't need the open parentheses. Try that. No, something else. Return factorial of N over factorial of R over factorial of N minus R. Right. Why is it stuck? 9C3. Well, I did 9C. Yeah, I did 9C. Spell something weird. Factorial, factorial, factorial. Why is it stuck like that? It's weird. That looks right. Something like this return. Doesn't like it. Why the heck? What is going on here? Is it really? It looks like it looks like it entered first before it did a shift enter, right? Yeah, something really with the keyboard. What, you see it? Oh, colon. Yes, there it is. It's always something silly like that.
Come on, what?
Ta-da! Yeah, you indented by hand. If you put the colon there, then that's for you. So you know that it's correct. All right, who else is stuck? Okay. All right, so let's take a look at a question from the homework. Now, tonight's homework, I think, is on page 850. Wait, let's take a look at Edmodo. Where's my Edmodo? Page 851, multiples of 10. All right, let's take a look at some examples from the homework. That's all you need to know to do this. Okay. Let's see, which one's good? Take a look at, say, 20. All right, now, oh, wait, 20's on the homework. Whoops, you had multiples of 10 tonight. I don't want to do the homework. I don't want to do the homework. Hang on. Let's see, something like that, though. It starts on 851. Why am I doing homework? I don't want to do that. Hang on. I'm looking at the wrong page. I'm looking at the homework. Ha ha ha. I went over the homework last year with this, so I'm looking at the wrong thing. Hang on. Oh, here you go. How about number 17? That's what I want to look at. Okay. 17 says expand 3x plus 1 to the fourth, right? Okay, let's try that. This is page, wait, this is number 17 on page 851 in the textbook. It says, what is 3x plus 1 to the fourth? Okay. 3x plus 1 to the fourth. Now, you could simply do this. Yeah, that's what I'm saying. How do you do this on paper? Hang on. This is related. You could expand it, like this. Now, is this correct? Can I do this? Just copy this? You got it? What's missing? The little multiply. Right. Okay, so put that there. Now, of course, I could make Sage do it for me. Thank you. Fine. But the question really is to show the work. On paper, how would you show the work? You'd have to do, well, all right, let's do it on paper first and see if we can replicate this on Sage. So my smartboard is paper, okay? Okay. Well, I'm using Pascal's triangle, but I'm not. I'm really using the factorials. Yeah, I'm really doing the factorial thing. All right, look. This is 17 on page 851. What is 3x plus 1 to the fourth? Okay. Now, here's the pattern, okay? Let's see if we can figure out this pattern. It's 4c0. Expansion theorem, you did this last year. Plus, what's the next term then? Plus what? 4c1 times 3x to the third times 1 to the first. I mean, it matters. What if it's not a 1? What if it's a 2? What if it's not a 3? What if it's a negative 3, right? That's part of what you're foiling out. All right, plus 4c2 times 3x squared times 1 squared. 1 squared is 1, but what if it wasn't 1, right? Notice the exponents are always adding up to what? 4. To the 4 that you started off with. And you're taking every power of the first binomial, counting down 4, 3, 2, 1, 0, and every power of the other binomial backwards 1, 2, 3, 4 the other way. So how many more terms do I need? 2 more. Plus 4c 3x to the first, 1 to the third, and then 1 more. Plus 4c4 3x to the 0 and 1 to the 4. Okay, so let's work this out. What's 4C0? Well, think of it. 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 1. Don't you know it? Now, if you don't know it, you can do the rule. 4 factorial over 0 factorial over 4 minus 0 factorial. It's got to be 1. 4 factorial over 1 factorial over 3 factorial. It's got to be 4 if you work it out. Okay, so let's do this. It's 1, 4, 6, 4, 1. You could use the rule we just wrote in Sage, or you can use a triangle. Now, what's 3x to the fourth? 81x to the fourth, and clearly these are all 1s, right? So, times 1. 81. What happened to the 1? Ding. Okay, 81 to the x to the fourth, right? 3 times 3 times 3 times 3 is 9 times 9 is 81, right? Okay, so what happens here? 3x cubed, you write 27x cubed. Okay, 3x squared, you write 9x squared. 3x to the 1, you write 3x. And 3x to the 0, you write 1. And this is a 1, and this is a 1, and this is a 1, and this is a 1. What'd I do? 9x, we said squared, sorry. Ding. Yes. So what's your final answer, Regis? Well, this plus this plus this plus this plus this, right? So what's the first term? 81x to the fourth. Let's write it out. 81x to the fourth. Okay, what's the next one? Right, quadruple 27. Let's see, double it 54, double it 108, right? 108 x cubed. Okay. And then what's this one going to be? 54x squared. And what's this going to be? Plus 12x and plus 1. So you can use Sage or you can use the TID3, whatever you want to use to help you do this, but you show this. This is the work. You're still showing the work. Okay. Let's confirm that on Sage. Is that what we got? I think I asked it to expand that before, didn't I? Alrighty. Let's see. Let's see, Sage. What do you got? So what is it? 81, 108, 54, 12, and 1. 81, 108, 54, 12, and 1, and a fourth degree polynomial in standard degree, counting down from 4, 3, 2, 1, 0, x1. That's good. Can you show the work here? Yeah, we could do exactly what we did on the smartboard. Are you ready? Combo of 4, 0 times 3x to the fourth times 1 to the 0. Is that what we wrote the first term? Let's check. Let's go back to the smartboard. Is that the first term? All right. So we could do this right on the smartboard. I mean on the Sage, using our combo method that we wrote. Okay. What's the next term going to be? Let's see. It will be 4c1, 3x to the third, 1 to the first. Well, just to make the point that that's what's happening. In case it's not a 1, you know what to do, right? Okay. All right. So likewise, 4c, after 4c1, we did 4c2. After 3x cubed, we did 3x squared. After 1 to the 1, we did 1 to the 2, right? These are counting up from 0. These are counting down from 4, right? This is counting up from 0. And is that the next term? All right, so do you see a pattern here? What is changing? We had to change this number, right? The 0, the 1, the 1, the 2. Didn't we have to change that number? And then as a result, this number changes also. Is this the same? This number and this number match, yes? Okay, this number and this number match, right? But what is this thing? It's changing too. What does it have to do with R? This is for NCR, right? What does it do with R? This is R, but what's this? Right, so how do you make this add up to 4? R plus what is 4? R plus what is 4? R plus what is 4? no matter what r is. Not plus. N minus r? Is that right? Where n is the exponent, which is in this case not changing? All right, let's see. Can we do that? Look, let me do that. Let me go down here and do 4 r in range. Let's see. Now we want the integers. We want 5 terms, right? Okay, and we're gonna print out. Let's see, combo of 4CR, r is changing, times 3 times x to the. Now you said n minus r, but n in this case is a constant 4 times, and what is it now? 1 to the, well, let's make it obvious. 1 to the r. Is that the pattern? Is that the binomial expansion theorem? Is that what we did? Let's see. That's what we did. That's the binomial expansion theorem right there. Okay, so if you're doing, how should we write this? Can we write this down? What is the theorem? This is the theorem. We just got a pattern, right, in terms of r, right? Can we write that mathematically as a series? Isn't that a series? We're adding them up? How do you write that? Let's see. Any binomial, a plus b to the n, is going to be sigma as r goes from 0 to n, right? Of, let's see, ncr, a to the n minus r, b to the r. Isn't that what we just did? That's what we just did. So if we do 3x plus 1 to the 4th, what are we saying? R varies from 0 to 4, right? That's the n part, right? And you're doing 4CR, 3x to the 4 minus r. In this case, n is 4. It's just going to be 4. And then 1 to the r. Isn't that exactly what we did? We worked out all 5 terms. When we count r integer-wise from 0 to 4, isn't that 5 terms? We ended up with 5 terms, and each one had this pattern. What was it? 4C0, 3x to the 0, 1 to the 4, right? If r is 0, do you get that? And then 4C1, 3x to the 1, 1 to the 3, and so forth. Yeah. 4 minus 0. 4 minus 0. I did it backwards. I'm sorry. Yep. Good point. Good point. 4 minus 0 is 4, and r is 0. Right, you're right. That's what we did, though, right? That's the point. Okay. Ta-da! Okay. All right, YouTube, that's good for today. So page 851, multiples of 10 tonight. See how you do with that? Yeah.